Hey everyone, welcome back. We're into class 4 of our Algebra 1 course. Let's take a look at it. So, short, simple one today. We're going to talk about interpreting word problems. So, word problems are one of the ones that can cause a ton of issues when it comes to Algebra 1 or any math class really. And we also talked about vocabulary already, but we're going to talk about it in the context of a word problem. What are some action words you might come across that will determine, are you adding, subtracting, multiplying, dividing? And then how do you convert this word problem into an equation, and then of course go and solve the equation as well. So our essential questions for today are, what are some keywords we want to watch out for when we're reading word problems? And then what are some strategies for converting the word problem into an equation? Let's go. So word problems can also be called math models, and it's basically an attempt to convert a math equation or a topic that we're doing into a real life scenario. And I say attempt because sometimes the scenarios are a little forced. We just need something to work from. Sometimes they are very realistic. It's a mixed bag. Most of these things do occur in real life at some point, but whether those examples will be relevant or not to you right now is the key. So sometimes like a real life example wouldn't be appropriate for our age level, but it is something that we would use in real life. So it's worth putting into a simplified, kind of maybe forced word problem just to get you used to like how you would convert that to an equation and then try and solve it. So here are some examples of things we might see. So restaurants, parents giving you stuff. Money is going to be a big one that pops up, particularly when I am your teacher, because I am super interested in money. So I will use that as the core of a lot of the word problems I do. But there's a lot of applications to finances in algebra. So you will see a lot of our word problems will in fact use money as the example. So things like figuring out totals of bills, how much each person had, how much a total was if you know a fraction of it. You're going to use all of the skills that you have so far, so adding, subtracting, multiplying, dividing, solving equations, but with word problems kind of being the beginning point. So when you see a word problem like this, what we really want to look out for are the action words. So that sort of tells us like what's going on in this. Like in this one, at the restaurant is not really an important part of this problem. Like it's great that we have some context, but it doesn't really need to be there if we're talking about the equation. Mike and his 3 friends. So that's important because that tells me that there are 4 people involved. So there's a number in here, Mike and 3 friends. You want to make sure you're also including Mike in that and not just 3 friends. Decided to divide the bill evenly. So evenly and divide are some key action words that we want to make sure we've noted. So we've got some division going on, and then evenly meaning it was an even split. Each person is going to take an equal amount. If each person paid $13, then what was the total bill? So what we see is you've got the first part, which is the setup, and then you've got the extra information to help you solve it. So each person paying $13 is that extra part. And then what was the total bill is what we're actually going to try and solve for. So now let's think about it in terms of an equation. The total bill will be equal to cost per person times number of people or another way to think about it would be total bill over number of people. So they say, we're going to take the bill and split it evenly. And that would equal each person's portion or their share. So like these are some ways that we can think about dividing it up and writing an equation from it. So like total bill is the part that we don't really know at the moment. That's kind of like our output. So I'm going to leave that one alone for a second. So it's going to be, I'm going to use T for total. Total is equal to cost per person. So we've got X can be my cost per person, and then we've got 4 people paying into this bill, so 4X. At the moment, we've got 2 variables, the total and the cost per person. So this would be my initial equation. When we get into functions, what you will see is something like T of X is equal to 4X, and that just means the total based on the value of X and then it's equal to 4 times whatever x is. So this is actually one single variable, it's not two, which is a confusing part of functions. Then we go into the extra piece of information we were given. The total is equal to 4 times, and each person's paying 13. So then 4 times 13, t is equal to $52. So the total bill was $52. So you are going to be asked to set up equations and then solve it. I recommend getting a highlighter out and doing exactly what I just did. Highlight the key parts of the equation, and then also just write out almost a story for yourself, like, okay, how would this work? How would this equation be set up before I even try and put in letters and numbers? So like total bill would be cost per person times the number of people. And then I start filling in information. All right, second one. We've got last Friday, Trevon had $29. Day of the week, Friday, usually not that important unless there's going to be something like on Monday this happened and they did something each day, so you'd have to kind of figure out how many days were there. So, put a pin on Friday as to whether that's important information. The person's name is not. $29, most numbers are going to be important typically. They're not always. Sometimes they're distractors. Over the weekend, he received some money for cleaning the attic. He now has $41. How much money did he receive? So the Friday or the weekend had absolutely nothing to do with it. So we've got $29 plus some work equals $41. So we earned some money. And then, of course, we need to figure out, well, what is the value of the work? So 29 plus, I'm going to use W to represent work, equals 41. And work being how much money he made from doing that work. Now, this looks like an equation that we've been working with for the past couple of days. We would subtract 29 from both sides. So then we get W, so they would equal 0. W is equal to 41 minus 29, which would be 12. So work, he received $12 for cleaning the attic. Next one, after paying $5.12 for a salad, Narachai has $27.10. How much money did he have before buying the salad? So you notice this time I read through the entire problem first. That's really what we should be doing. Read through it once first, get it clear in your head. Okay, what's going on? Narachai is buying a salad. He paid $5.12 for the salad. He has $27.10 left. So how much did he start with? So key numbers here, $5.12, $27. He paid $5.12, so it's not like he saved it or earned this or anything like that. So paying tells me that that's a subtraction. So this is one of those moments where I'm looking for key words here, and pay would mean that I subtracted from what I had. And let's see, we've got how much money did he have before buying the salad? So not how much after, but how much before. So thinking about it, we would have money in wallets, so starting amount minus cost of salad equals remaining amount. So that's our story that we have. Filling in some of the gaps. Starting amount we don't know. I'm going to call that A for amount. Minus cost of the salad was 5.12, and the remaining amount is $27.10. So I filled in the information I know. Now I need to solve for A. We are subtracting 5.12 from it, so I'm going to add 5.12 to both sides to try and get A on its own, to get my starting amount back. So think about what we're doing here. We're saying I paid $5.12, I have 27 left. Well, if I reverse that, if I add the $5.12 back in, that would tell me how much I started with. So then the starting amount was $27.10 plus $5.12, so that would be $30 2.22, and then the unit we're in is dollars. All right, it is your turn. So what I want you to do, take a look at the 3 questions, read through them. First step, write an equation. So I'm not looking for just an answer. I want you to write out an equation, write the story, write the equation, then solve it for the solution. So when you look through each of these, make sure that you are doing both parts. You're writing the equation and then writing the solution. Pause the video, come back when you are ready to see the answer. All right, in the first one, we've got Julia ran 30 miles more than Pranav. Julia ran 47 miles. How many miles did Pranav run? So Julia ran 30 more than Pranav. Julia ran 47 miles. How many did Pranav run? So this one is, the key numbers here are 30 more than Pranav, and then Julia ran 47. So we have 2 people, Julia and Pranav. So Julia and Pranav. Their relationship is that Julia is going to be 30 miles more than Pranav. So Julia is equal to Pranav plus 30 miles. Then we get told, hey, you know what? Julia actually ran 47 miles. So 47 is how many Julia ran, and that is Pranav plus 30. So then we would be able to say, all right, if I subtract 30 from both sides, I can figure out that Pranav ran 17 miles. So, there's not much more here that we could do with this. You could have written something like Julia plus Pranav equals total miles ran, but you would have ended up having to rearrange that a little bit. Sometimes you're going to try things out. It's not going to work first time, and that's totally okay. Like, you can always go back and start again, and just figuring out something to try that didn't work is still a success. Next one, how many packages of diapers can you buy with $40 if one package costs $8? So I've got $40, and I want to know how many it can buy. So $40 would have to be equal to, or technically this is, and it should be an inequality, but we're saying it's going to go in equal. So $40 is equal to $8 packages times the number of packages. We don't know how many. So then to solve that, we would divide by 8 on both sides, and we would say 5 packages is equal to X. So we can afford 5 packs of diapers if they cost $8 each, and we have $40 in our pocket. Jenny wants to buy an MP3 player. This shows how old this question was when I pulled it off the internet. MP3 player that costs $30.98. How much change does she receive if she gives the cashier $40? So thinking about story, you've got price, and then if we add the, I guess let's think of it this way. I'm going to redo that. So we've got how much we pay, so the cash we have minus the price equals the change. That would be how you would determine change. So how much cash you hand over, take away the price of the item, and that would tell you how much change it is. Or you could say change left over plus the price would equal the cash we started with. We had a question like that earlier. But we are being asked to find the change in this case, so we would have $40 cash minus $30.98 is equal to the change. And I guess we should just call that C. So C for change. 40 minus $30.98. You can do that in your head if you would like. So if I added 2 cents to this, it would be $31. And 40 minus 31 is 9. So the answer is $9.02 is what the change should be. It's very much like how would you do that in your head. So like $30.98 was our key stuff, 40 was ours. We want to know how much change. So we know change comes after you pay for it. So that's kind of getting the clarity on your situation and then going to solve it. All right, we're going to look at slightly more complicated word problems now. So the first one was more like single step, like a lot of those you're probably doing in your head. You may still be doing these in your head, but this is going to look more like the problems that we were doing in class recently. All right, 331 students went on a field trip, 6 buses were filled, and 7 students traveled in cars. How many students were in each bus? All right, so now this is kind of more like what we're doing in class. So 331 students total. We had 6 buses that were filled, so there's no like remainders or empty seats or anything like that, and 7 students traveled in cars, so they went without a bus. How many students were in each bus? So if we think about how this would kind of play out, the total students had to travel in buses or cars. So they're traveling in buses or cars. We had 6 buses, so 6B, plus 7 students traveled in cars. So we know that there was 7 students who went by car. We know the number of students. That's why I'm not putting a C in here. B is there because we don't know how many students were in the bus. So we had 6 buses, but we don't know how many in each. I guess if we were going to do this, we would say 7 cars, but we know there was 1 person in each car. So if that's what it takes for it to kind of make sense in your head, that's fine. And total number of students was 331. So we're going to need to solve for B. Subtract 7 from both sides, or reverse PEMDAS. Any addition subtraction goes first, so they cancel. 331 minus 7 is 224, is equal to 6B. 6 times B, we want to get B on its own, so we're going to divide by 6 on both sides. So divides over there. 224 divided by 6 is, 324, not 224. So 324 divided by 6, that would be 54. So 54 is equal to B. So each bus held 54 students. So bus equals 54 students. Next one up, Leah had $24 to spend on 7 pencils. After buying them, she had $10. How much did each pencil cost? So key information here, $24, 7 pencils, and noticing the numbers when they're written in numeric form or in alphabet form. And after buying them, she had $10. So it was after buying, there was $10 left. How much did each pencil cost? So we got starting money minus pencil costs equals remaining. So starting money, 24. Bought 7 pencils, so 7, and we don't know the cost of a pencil, so minus 7p, and then we're left with $10. So we want to get p on its own. We're going to subtract 24 because it's, even though there's a minus between them, like it's 24 minus 7p, the 24 itself is positive. So to get rid of that, we're going to subtract 24 from both sides. So 24 minus 24 is 0, minus 7p, so the 7 is negative, is equal to 10 minus 24, which is negative 14. We need to get p on its own, so we're going to divide by negative 7, divide by negative 7, minus 14 divided by minus 7, 2 negatives dividing, which means the answer is going to be positive. P is equal to 2. So that means a pencil is equal to $2. And if you ever pay $2 for a pencil, you are in the wrong store. Go find a different store. All right, last example. On Tuesday, Shanice bought 5 hats. So again, seeing the word version popping up as opposed to numeric. On Wednesday, half of all the hats, there's a fraction in here, half of the hats she had were destroyed. On Thursday, there were only 17 left. How many did she have on Monday? So it doesn't look like the days of the week really matter at all, just that there's, I guess, some sort of order to what happened. So starting number of hats minus destroyed hats. Actually, we're missing a piece there. So before we destroy hats, we have to buy new hats. Starting hats plus buy new hats minus destroyed hats equals remaining hats. All right, so starting hats, we don't know, but Monday comes before Tuesday, so that would be our starting number. This is the one we don't know. So let's put H for hats. And then we bought new hats. We bought 5 hats, so plus 5. And then half of all the hats she had were destroyed. So it's a fraction, and it's based on all the hats we have. And all the hats we have will be H plus 5. So the way we're going to do this is put it in parentheses. We're going to say hats plus 5. This is total hats. And then it got cut in half. So you can say divided by 2, or you can multiply by half. It doesn't matter to me which one you do. And that equals remaining number of hats, which was 17. So this one is one of those more complicated questions that we had to solve. And the word problem, of course, is that little bit more complicated too. It is a skill to be able to transfer these things from words to equations. And again, like most things we do, that only comes with practice. So now to solve it, we've got a half times H plus 5 equals 17. You could distribute it. So that would mean you'd have a half H plus 5 over 2 equals 17. It's not great, but it'll work. A half H is going to stay. 5 over 2 as a decimal is 2.5. Some of you like decimals more than whole numbers or more than fractions. So then we would subtract 2.5 from both sides. And I'm going to need some space. So I'm going to just kind of scoot it in here. So then we would have a half H is equal to 17 minus 2.5 is 14.5. To get rid of a half, remember we have to multiply by the inverse, or we have to use the inverse. So the inverse of a half is to multiply by 2 over 1. So you flip a fraction over. So 2 over 1 times a half H is equal to 14.5, and that would also have to be times 2. So a hat, or the number of hats, would be 14.5 times 2, which is 29. So this person owns 29 hats, which is a lot of hats. Maybe she works in theater, or maybe she's like a hat collector, in which case, sad day that they were destroyed. But yeah, 29 hats is the total. And when you're doing this in your notebook, try and give yourself a bit more space. I did not. I like spread it out to begin with, and I was like, oh wait, I gotta do some solving too. Your turn. 2 questions this time. I want you to try again to write the equation and then solve it. So 2 parts, write the equation, and then solve the equation. Pause the video, come back when you're ready to see the solution. Okay, so Patrick invited, let's see, 39 of his friends to a birthday party. 5 said they couldn't come, and he's going to have 5 party favors for each. So for each person who comes. That means every person gets 5 favors. So for each is actually going to indicate some multiplying. What am I doing there? So we got, so for each is a word that would indicate some multiplying is going to go on because everything is going to get something. So there's going to be a distribution going on. And then how many party favors does he need to buy is that final question. So how many? So when we're thinking about this, we've got invites. So number of people invited minus declines. That's going to be the number of people who attend. And then attendees times favors is going to equal the total number of favors. And they're each getting us 5 favors. So we can put that in there. Total favors. Now in a single one, what we would do is say, okay, so attendees times 5 favors, so we're going to actually put invites and declines in parentheses, and then we can multiply that by 5. So this is going to look like number of invitees was 39. 5 people said they couldn't come, so minus 5. So there's my total number of attendees. We need 5 party favors for each person who comes, so times 5. And that'll equal our total number of favors needed. So I'll put T in there. So 39 minus 5 is 34, times 5 is the number of favors. 34 times 5 is 150, plus 20 is 170. So total favors needed. That is why when you are planning a wedding, the number of guests you have is probably the biggest determinant of your cost, because every time you add a guest, you add in multiples of things like number of favors, seats, cutlery, food, all that sort of thing. So moral of the story is keep your wedding small if you want to keep the cost low. The cooking club made some pies to sell at a basketball game to raise money for new math books. None of that is like really relevant at the moment. The cafeteria contributed 4 pies, so there's some numbers to the sale. Each pie was then cut into 5 pieces and sold. There were a total of 60 pieces to sell. How many pies did the club make? This is almost one where a picture does a better job. So you've got the club pies. So club pies plus cafeteria pies equals total pies. But then each pie was cut into 5 pieces. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then, so like how many slices did we have? So, you know, a slice being 1/5 of a total pie. So cooking club, we don't know how many they gave us. And cafeteria gave us 4 pies. And we had 60 pieces to sell. So 60 pieces equals, we've got the cafeteria did 4 pies times 5 pieces. And then the club did, we don't know how many pies, but each pie had 5 pieces. So we could do 5p or p times 5 to solve this. All right, so then we can, 4 times 5 is 20. So we know we can do that, and then plus 5p equals 60. We can subtract 20 from both sides. So we get 5p is equal to 40. And then we would have to divide by 5 on both sides to get the number of pies. So 40 divided by 5 is 8. So the club contributed 8 pies, the cafeteria contributed 4, and then just to double check our math, 8 plus 4 is 12, and 12 times 5 is 60. So check, that's how we would get our 60 pieces. All right, so we're going to do some more practice. We're going to do it in Khan Academy though. So this will be the first time we've logged into Khan Academy. You're going to follow the instructions in class. If you are watching this from home, the link to join Khan Academy is posted in your Schoology folder. You click on that. You want to make sure that you are logged into my class, so Mr. Phelan's class, and then send me a message on Schoology to let me know you've done that, because once you've done that, I need to just add the assignments to your name. If you're watching this or at a later time just to review, you should already have had it. But yeah, we're accessing Khan Academy and completing the assignments that have been assigned to us. So you should see those on your dashboard. If you're logging into this a couple of weeks later, they may be in your past assignments. So when you're on your dashboard, you can look at active assignments, which are ones that have a due date in the future, or past assignments, which had a due date in the past. You can just click on past assignments and then complete the assignment. All right, essential questions. What are some keywords we need to look out for when reading word problems? For each popped up, and, subtract, pay was a good one for money words, like that indicates subtraction. Divided evenly or split the bill, like there's some division words. You can start making a list of vocabulary words that are kind of action words for math problems, and that's a good way of kind of figuring out what's going on with math problems. 2 strategies for converting word problems to equations for solving: highlighting the keywords, writing a story first, then converting it to an equation, and then solving it are some of the ones I would recommend. Drawing pictures can be a good one, sketching out the story if you feel like, okay, I need to really get a visual what this might look like, or using symbols instead. Those are all valid things to do. And then your work for tonight or for later is to work on your Khan Academy assignments and get those turned in. So to get logged into Khan Academy and then complete the assignments. Talk to you all soon.